In this lesson, we'll learn how to use the trigonometric product to sum formula. The first question reads, write the product as a sum or difference containing only sines or cosines. For question A, we have sine 4 theta times cosine 2 theta. Let's take a look at the formulas for product to sum. Whenever we have sine times cosine, we use this variant shown right here. So I want to begin by setting alpha equal to this angle, 4 theta, and beta as 2 theta. And using what we have right here, I'll expand sine alpha times cosine beta using the right side of the equation. So I have half bracket sine, and alpha is 4 theta. So I have 4 theta plus 2 theta, that's 6 theta, plus sine, again, 4 theta minus 2 theta is 2 theta. From here, I will distribute the half into this expression, and I end up with sine 6 theta over 2 plus sine 2 theta over 2. As you can see now, the expression is completely written in sine as opposed to being sine and cosine. For question B, we have cosine 19 theta over 2 and sine theta over 2. So once again, I'll assign this as alpha and that as beta. Let me write that down here. Alpha is 19 over 2 theta, and beta is 1 over 2 theta. Let's see which of these formulas will work. This one right here specifically. And by using that formula, we'll have an equation that's entirely in terms of sine. So sine alpha plus beta, we add these two up. So adding fractions, 19 over 2 plus half. They both share the denominator 2, so we can combine the top. 20 over 2 is 10. So I have 10 theta minus sine, and now we subtract them. If you subtract them, you end up with 18 over 2, which is 9. So I'll write down sine bracket 9 theta and close. Now keep in mind that these two are not like terms, so again we multiply that half into both of these, and we have sine 10 theta over 2 minus sine 9 theta over 2. In question 2, we have determine the exact value of the expression without using a calculator. Okay, I'll assign this angle as alpha and that as beta. And using this version of the product to sum formula, I'll substitute those values into wherever I see alpha and beta and over here as well. So I have half, open bracket, sine alpha plus beta. Let's go ahead and add these up. I have 3 pi over 8 plus pi over 8. Luckily, the denominator is the same, so we keep that common, and we get 4 pi, which reduces down to pi over 2, because 4 over 8 is half, times pi is pi over 2. So I have sine pi over 2. For this term, we will be subtracting those two numbers. So rather than plus, we do minus. It's the same sort of math. We have 2 pi over 8 is equal to 1/4 pi. So plus sine pi over 4. All right, now we need to find out what sine at this angle is. For this, we can recall what a sine wave looks like. At pi over 2, we're at 90 degrees, and a sine wave reaches its maximum at pi over 2, which is 1. So I have 1 in place of this. For this term, we have sine at an angle of pi over 4. Like I said, you need to know your special triangles, and the special triangle associated with this particular angle is shown on your screen. You should end up with a ratio of the square root of 2 over 2. Okay, now we expand just like how we did in the first question. We get 1 over 2 plus the square root of 2 over 4. And you can combine this further. The common denominator between these two is 4. So I'll multiply this by 2 and that by 2, and we get 4 as the common denominator, 2 plus the square root of 2. Now, had you not rationalized this term earlier, you may have gotten a different expression as your final answer, but both of them mean the same thing mathematically. And there you have it. That is how to use the product to sum formulas.